Okay, this is part 2 of section 5.5, solving logarithmic equations. Okay, so we're going to look at this a couple of ways, but there are some main ways that we can solve this equation, or these types of equations. Okay, so the first one is pretty straightforward. Log base 2 of x is equal to -3. Okay, and so what I could do is remember that I can always write between exponential and logarithmic equations. I can convert back and forth. Well, if I do that, remember, 2 is the base. Here's the exponent. So my exponent is -3, and this equals the interior x. Notice x is by itself now, right? I just need to translate this 2 to the -3 power. Remember, a negative exponent just means it's a reciprocal. So put it in denominator. And then 2 to the third power is 2 times 2 times 2, which is 8. Don't say 6, right? It's 8. Now, with logarithmic equations especially, you have to make sure that whatever you're plugging in will not give you a negative inside the logarithm, okay? And of course, in this problem, that's not an issue, okay? We're plugging in a positive 1/8. Okay, let's do this another way. And the more useful way, I guess long-term, depending on the problems that you come across later, another way to do this problem is to use its inverse, okay? And so, like in the previous video, we put logarithms on both sides, okay? Well, remember, another one of our rules is that if you have a number as a base and the exponent contains a logarithm that has that same exact base, right? They have the same base, and this is the whole exponent. Those would cancel out to leave you with x, right? That inside part. So I'm going to use that rule. I'm going to say my base is 2. So I'm going to write 2 on both sides. Let me use a different color. Let's say 2. And the left side becomes the exponent on the left. The right side becomes the exponent on the right. Okay, so doing it this way will allow me to say, all right, those cancel out. X is now by itself on the left side. 2 to the -3rd power, we already discussed, is 1/8. Okay, so either way. Again, the one on the right is a little bit more useful for other types of problems. So it's a good method to know. Let's go on to example 2. So log base 125 of 1/25 is equal to x. Okay, well, the nice thing about this one is x is already by itself. All right, so all I need to do is figure out what to do with this thing. And remember, there's different methods. I can use the change of base formula, which is just going to be ln natural log of the interior divided by natural log of the base. Okay, and if I type that in, I actually get a decimal. It's going to be -0.6 repeating, okay, which you may know is 2/3, which is the answer that I'm looking for here. Another way you can work this out, though, is, okay, let's work with the exponents. So 1/25 is the same thing as 1/5 squared, which is the same thing as 5 to the -2nd power. Okay, so that numerator, ln of 1/25, is the same thing as ln of 5 to the -2nd power. Okay, 125 is the same thing as 5 to the 3rd power. I'm writing it like this because I want you to recognize something. Remember, one of the properties of exponents is that you can take the exponent, property of logarithms is that you can take the exponent and bring it out to the front. And so I could rewrite this as -2 natural log of 5 over 3 natural log of 5. There should be a negative because I didn't carry my negative over. Look at me making silly mistakes. Yeah, when you write it like this, you can see that those two would cancel to leave you with -2/3. So that's actually a little bit better way to think about it. But again, if you remember, if you type that in the calculator, you may just get it that way. But negative 2/3. I don't have to worry about this being a negative being plugged in, right? Because all I worry about is inside the logarithm, right? And there's no x. If I plug this in, it'd be plugging it in here. So not inside the logarithm, no negatives inside. All right, let's get to some more interesting problems. So 2 more. Okay, third example. Log base 5 of 8 minus 7x equals 3. Equals 3. Better 3. All right, so I'm going to use the method that I used in the first example on the right side here. I'm going to say 5, or on the right side of the first example, I should say, right, where I used the base of the logarithm as a base of an exponential term so I could cancel them out. Okay, that's the method I'm going to use here. So 5 goes on both sides. Let me use a different color. Okay, and then the exponent of the left side becomes, or the left side becomes the exponent of the left side. The right side becomes the exponent of the right side. 5 log base 5 cancels out to leave me with 8 minus 7x equals 5 to the third power is 125. Okay, regular equation here. Solve for x. Subtract 8 from both sides. 125 minus 8 is 117. Divide both sides by negative 7. I get negative 117 over 7. All right, so again, I need to check to make sure that if I plug this in, I don't get a negative inside of the logarithm, right? And so if I look at it, let's see, if I look at the negative 117 over 7, I end up imagining that I'm plugging this in right there. And if that's the case, well, I have nothing really to worry about, right? Because imagine what happens if I plug in a negative number right here. Plugging in a negative number right here would give me a negative times a negative, which would translate that into a positive, right? So I end up with an addition problem. As long as I have something positive there, it's fine. So negative 117 over 7 works out just fine. Okay, one more example. Let's solve log base 5 of x plus 4 plus log base 5 of x minus 4 equals 2. Okay, I want to use the method that I just used a second ago, but I have 2 logarithms instead of 1. But remember, one of the properties of logarithms is that if there are 2 logs added together, 2 logarithms with the same base that are added together, I can write them as 1 logarithm. Right, write them as 1 logarithm with the interiors multiplied together. Okay, so I was able to condense it a little bit. Okay, and x plus 4 times x minus 4, that's some difference of squares. I can actually just multiply that out and get x squared minus 16. So log base 5 of x squared minus 16. Okay, I want to get rid of log base 5, so I'm going to say 5 is my base on both sides here. And each side becomes the exponent. Cancels out, leaving me with x squared minus 16 equals 5 squared is 25. Add 16 to both sides. X squared equals 41. Now remember, square root property says that I can take the square root of both sides. I'd get positive and negative square root of 41. Okay, but I'd have to be very careful with these solutions, right? So square root of 41, by the way, just off to the side here, is somewhere about around 0.6, or 6, not 0.6, 6.4, or something like that. Okay, so just keep that in mind as a reference. Imagine that you plugged in a positive 6.4 here and here. 6.4 plus 4 would be 10.4. That's good. 6.4 minus 4 would be 2.4. That's good. I have positive numbers inside the logarithms. Positive square root of 41 is fine. Okay, what about negative, right? If I threw a negative in the front, negative 6.4 added in here, so negative 6.4 plus 4 would be a negative 2.4, right? I can't do that. Negative 6.4 minus 4 would be a negative 10.4. No way can I plug in negative square root of 41. So this one only has one solution, positive square root of 41. Okay, and I do want to comment real quick. Be careful with these problems. Check the wording, right? If it says, give me the approximate value, then you need to type in 6.4031, right? That would be the approximate value. If it asks for the exact value, then you would just type in the square root of 41. Okay, so just watch for the wording. Okay, so that would be the rest of section 5.5.